So welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video and also subscribe to our channel. In this platform, we have over 160 videos available for you to watch with different topics. It means any topic you are having problem with, you are good to go. You can learn from O level, from any level, and anyhow it comes. This video, I want to be walking you through Fourier series. I want to be working on Fourier series. Now we have done our some things on Fourier series. Wow, what is being how it's being formed, and which is, you have to watch our previous video before this one, which is integration, useful integral in Fourier series. We have done that. Please make sure you view that. Now, when we talk about Fourier series, I told you earlier that you must understand what is called series, which is, it can be Maclaurin series and Taylor series, and also you know what is called trigonometrical series. Trigonometrical series. It means those are the things we are working on, and because of periods, we are talking about periods which I've showed you how it's being formed. Period being formed in our previous video. You can also learn that. But now, when you talk about Fourier series, the Fourier series corresponding to f of x in the interval of minus c less than x less than c, and is given by f of x equals to a naught all over 2 plus, which is from 1 to infinity, of a of n cos nx all over c plus summation of n to 1 from n equals to 1 to infinity, which is we'll be talking about b of n sine nx s pi else. That is what's all about on Fourier in a function, which is this is a function of what? Fourier series. Now, take note as where are coefficients a n, and b of n are a naught equals to, which is 1 all over c integral of minus c to c f of x this x. That is my a naught. Now, if I'm talking about my an, it will be integral run from 1 all over c, integral run from minus c to c, which I'll be talking about f of x and cos nxx all over c dx. And also, when I'm talking about b of n, it will be 1 all over c, integral run from minus c to c, f of x and sine nx pi all over c dx. Now, that is these are my coefficients of those things. It means this. Now, what I'm trying to say there is that I can now say that my general term of it, you can do a lot of things. Please take note of that. This is how it's being formed. This is what is called Fourier series, and these are the coefficients, the a naught, an, and bn. They are just in form of this. Now, there's not much to say here. Then let me try to do one or two examples that can help us because there's no time with us. Now, with the help of my example, you understand how to compute this Fourier series. It's a very simple part of mathematics. What you just need to do, try to understand your integration very well and the trick, application behind trick, how to work on trigonometry very well. Now, for instance, construct the Fourier series. Fourier series of f of x equals to, which is minus x when pi run from to x to 0, and is 0 when my x less than pi. Now, what we are trying to do there is that a solution to this problem. This is a very good question that we need to understand. When you have this type of problem, it's very easy to handle. But the most important thing is ability to handle your integration very well when you are integrating it. Integration very well. I mean, trigonometry when you're handling it. Now, when I have something like this, it means I'm coming from minus pi to what? To a 0, which is the whole band is what? Solution. Now, the band is just like, it's coming from minus pi to pi. That is just the meaning. But it's stopped by the way. You have to understand how it means on. It means when you have it that way, it will be always like this. My A, sorry, let me go first show you what my Fourier series is saying. A of n all over 2 plus summation of n to 1 to infinity, and A of n cos n pi x all over c plus summation run from n to 1 to infinity b of n sine n x pi all over c. Now that is what my Fourier series is saying. Now, since I have it this way, I will now go and do the one of a of n and b a of n, a naught, and b of n. Now, it means my a of n, it always be equals to, I've told you it will be what? It will be running from minus pi to pi, which is I'll be having this run from this to this. It means I'll be having integral 1 all over pi, which is my c. I've done my substitution. It will be running from it will be 1 over pi. It will be running from minus infinity to 0, which is I'll be having minus x, the x, which is my function. I've just introduced my function, which is I'll be having plus 1 all over pi, and also integral run from 0 to infinity, which is from here to here, from here to here. This one is from here to here and continue from here to here, which I'll be having this one will now be 0. I have the function at 0 and the x 0 the x. That is all about it. Without doing much, this one is already becomes nothing, which is render useless. Now with that, I can now say that what my a of n equals to 1 all over integral, which is when if I integrate this, I'll be having minus 2. I mean x squared all over 2 run from 0 to minus infinity, which is when I do the upper limit and lower, which also implies minus 0 squared all over 2 minus plus minus pi squared all over 2, which is I'll be having pi all over 2. Now, which I'll be having my a of n equals to I have pi squared divided by 2 pi. Pi squared divided by 2 pi, because I'm having pi, yes, pi will be here. This one will become 0, which is squared, it's going to be squared. This one will be squared, sorry, this one is not there. Now, Yes, minus minus to be plus. Now, since I have that, it will be equals to pi all over 2, which is this will cancel this. Now it means my a of n equals to pi, my a naught equals to pi all over 2. Please, I need those things. Now I'll move on to the next one, which is going to be my a of n. My a of n will be 1 all over pi, integral run from minus pi to minus pi to 0, now to 0, and also minus x cos x all over c all over pi, which is the x, yes, the s plus. Now I'll be having 1 all over pi, integral run from 0 to pi, which is I'll be having 0 cos pi x all over dx. Now everything becomes useless because of the 0 has neutralized the whole system. Now since I have that way, I will have a of n equals to 1 all over pi. Now I want to integrate. How do I integrate? That will be very fast for me to go, which is I'll be having okay, with what I'm having here, I'll be having okay, can I integrate it so I can write? Okay, now without doing much, I'll be having pi 0 minus x cos pi n x, the x all over. Now this one will now be, this will cancel this, which is nx, the x. Now with this, I am good to go. Now with this, I can go for my integral by parts. By now, integral by parts, we have done it earlier, which is I'll just say I can say let everything be equals to, let my u equals to minus s, and my dv equals to cos ns dx, which I will have the u equals to minus 1 dx, and also v, it will be equals to, when I integrate this, I'll be having 1 minus 1 over n sine, I'll be having sine, now sine n x dx, sine n. Now that's what I'll be having there. Now with that, I think I'm good to go. I can now go to by integral by parts. We have done that earlier, which is I can say that what u v minus integral of v du, which is, we have done that earlier. I think I don't need to do that again. With help of that, we have done that before. Now, which I'll be having this I'll be having a of n can be equals to x all over n sine nx integral run from which is our limit of minus pi to 0, and also minus. Now the next one will now be equals to, it will be okay, when I have it this way, okay, I will now be having okay, now I'll be having 1 all over n squared, 1 all over n squared, which is integral of, I'm talking about v du. Now integral of it will be integral of, which is plus will be here. Now plus will be here, which is integral of cos. It will be cos. No, I'm talking about v du. V du. Okay. Yes. Okay. Integral of sine nx dx. Now when I have it of n, we have x all over n sine nx is 0 pi all over this, plus when I integrate this, I'll be having 1 all over n squared cos, okay, it will be running to. Now, but not about cos will come out there, which is I'll be having cos nx run from 0 to minus pi. Now, when I do this, I think with my upper limit and my lower limit, which I'll be having a of n equals to, what else can I do there? I think I'll be having, now this one will be coming 0, 0, 0, which is to be cancelled. This will be cancelled because it won't come. Sine 0 is always 0, and sine 180 is always equals to 0, which is, that's what I mean. Now we now be working on 1 over n squared cos nx 0 to minus infinity. I mean to minus pi. Now with this, I can now move on by having a of n equals to 1 over n squared. Okay, upper limit and lower limit. It will be cos 0 minus, and it will be cos 0 minus, which is going to be minus cos n minus pi, cos n minus pi, which is, I'll have something like this, which it will give me a of n equals to 1 all over n squared. We have 1, which is cos 0 is equals to 1, and this one will be minus 1 of n power, which is equals to, because this is negative of it, which is power of n. Now I'll have that, which I can now say that my a of n, it means my a of n equals to 1 all over n squared bracket of 1 minus 1 n. Now, since I have this way, now what next can I do? I need my what? My b of n. I generate my a naught and a n remain b of n. Now my b of n, that's what I'm trying to work towards now. It means I'll be having equals to 1 all over pi integral of what? Run from minus pi to infinity, which is f of x sine pi n x all over c all over pi. All over pi. Let me just put all over pi dx. Now that is the whole function. That is how it comes. Now it means I'll be working on. Now it means I'll be having. Normally this will cancel this. B of n equals to 1 all over pi integral of minus x pi to 0 minus s, which is my function sine nx dx, and also plus integral run from 0 to infinity to minus pi, which I'll be having 0 sine x dx. Now normally this one will be coming to nothing, which is to 0. It's to 0. 0 can be added there because 0 multiplied by everything become 0. Now I can now continue by having my b of n equals to 1 all over pi integral run from pi to 0 minus x sine nx dx. Now since I have this way, I'm good to go. I can now roll to my what? Integral by parts, which is having something like this. Let u equals to minus x and the v equals to sine nx dx. Sine nx dx. Since I have this, the u equals to minus the x. Now also my v will be equals to what I have. It will be equals to 1 all over u cos nx. Now since I have it this way, with the help of my integral by parts, which I've introduced, that my integral is always u b minus integral of b du. Please don't forget that. It's very important. That's what I'm working on. It means you must be very, very good when it comes to what? Integration by parts. That is what I'm trying to work on now. What can I do here? I'm now on my integration by parts, which I'll be having. What can I? What? Okay, u and v minus x all over n cos nx bracket of 0 to minus pi. 0 to minus pi. Now, once I have this particular one, what can I do next? Okay, upper limit and lower limit, which is my lower limit will now be minus, it will be plus. Minus will be plus. It will be okay. It will be minus. I have okay, I'll be having 1 all over n. 1 all over n integral of what? Cos nx dx. Yes, integral of yes, minus, which is going to be minus, which is going to be plus. Now that will be plus. Since I have it as plus, what next can I do? It means if I should integrate this, I'll be having I'll be having minus b of n equals to minus s all over n cos nx minus pi 0 plus. Now if I integrate this, I'll be having minus, which is I'll be having minus now minus 1 all over n squared. It will be sine nx dx. I mean sine n in the bracket of what? Minus pi to 0. Now it means what I'm right done, I've successfully run towards my what? Integral by parts. With the help of my integral by parts, normally pi at the point of sine, it will be what? It will be vanish. Because of sine 0 is equals to 0 and sine 180 is equals to 0. It means at that period of 0 of, this is what we're talking about here. Now at this period it will be 0, that's what I'm trying to work on. No matter how it is, it will be 0 vanish. It means I don't need to stress myself on that point of what? 0. Since I have that, I can now move on to my upper limit and my lower limit, which is b of n equals to, now is 0 of n cos 0 minus, now this one will now be minus pi all over n cos 0 cos n minus pi. Now okay, that is what I'm having here. Now normally here would be 0 because 0 would affect everything there. Now since I have it that way, this one will now be I'll be having okay. Now with this, don't forget that I'm relating with something here. This my n, I've not been using it very well, which is I neglect it at this point. Now it means I've not used my n for a long time. B of n equals to 1 all over pi. This one will now be minus pi all over n, and now it will be which is a period, and it will be n minus n minus 1 bracket of what? N minus 1 bracket of n. Now this we cancel this, that we cancel that. Since that has cancelled that, I'll be having b of n equals to okay, yes. Now b of n equals to, this is plus already, which is going to be now, yes, plus, which is plus, this is plus already. Okay, this is plus on, okay, now which is a value minus 1 bracket of n all over n. Now I can now establish my Fourier series. What is my Fourier series? We have something like f of x. Okay, let me quickly establish my n. It means my b of n equals to minus n bracket of n all over what? All over. Now that is my Fourier. Now I can now establish what I need to establish, which is to establish that I can now move on by having my f of x equals to, we all know that a of naught of 2 plus summation of n to 1 to infinity a of n cos n s I all over c plus summation around this to infinity b of n sine n s pi all over c. Now, since I have it this way, it means my function of that, it will be equals to, what is my a of n? My a of n is pi, which is pi all over 2 times 2. Pi all over 2 multiplied by 2, which is going to be 4. Plus, now, summation run from n to 1 to infinity. What is my a of n? My a of n is equals to 1 all over n squared bracket of 1 minus 1 n of n. We have what? Cos nx pi. Okay, cos nx. Yes, at this point we are working on pi. Yeah. Now plus, okay, cos nx okay. Now plus, I'll move on to the next one, which is plus summation of n run to this to infinity, which is I'll be having, what is my b of n? My b of n is equals to minus 1 of n pi bracket of sine n x pi all over, okay, all over n. This one is out of it. Now that is my Fourier. That is the series we are talking about. That is the series we are talking about. Once again, you can go on and so on and so forth. These are the series. That is how series being formed, and now you should know what is series now. I think I'm happy to get to this level. Now try this and make sure you generate something like this. Drop your comment after. I will surely attempt to hit. Drop your comment after. Let me show you 1 or 2 series. Okay. Just construct the Fourier series for the function f of x equals to x all over 2 from interval of minus 0 to 2 pi, 0 to 2 pi. Okay, and another one, number 2. I would love to see it. Drop your comments below. I'll be happy to see it also. Construct the Fourier series for Fourier series, the function okay, construct the Fourier series over, let me just put over an interval, over the interval of minus 2 to 2. It must be a closed interval, closed interval of that for the function defined by f of x equals to we have x. This one is minus 2 to x to 0, and this one will be minus 2x to 2. Please try these two questions. It will really be of help. I think we have done a lot of things on Fourier series. We'll see how Fourier series is being formed. Now, make sure you practice after you have learned, and don't forget to subscribe to our channel and share further solutions academy. Help us to share the video and also subscribe to the channel. Help us to share and subscribe. Thanks for watching.